Okay, in our last class, we discussed about organoselenium compounds. Okay, so more particularly preparation and applications. Okay, so today we will discuss about organomercury compounds. So that means carbon Hg. Hg is called mercury. So I think you are aware that this is the only metal which is in liquid form. Okay, so normally where you can find, so you can found in the thermometer. Okay, thermometer contain mercury. Okay, so then what here we need to know, so it exists in two forms. One is mercurous, means Hg plus, and mercuric, Hg 2 plus. So mercurous is highly unstable, mercuric is a little stable. So then dialkyl mercury. So dialkyl mercury means when Hg is bonded with two alkyls. Two alkyls may be a methyl, propyl, whatever it is. So then our liquid are low melting solids. So dialkyl mercury is an organomercury compound. It is a, a liquid or low melting solid, these compounds. And generally, these are crystalline and soluble in water. So organic compounds, more particularly alkyl mercury, alkyl mercury compounds, are crystalline and soluble in water. So let's go to the preparations. Here I am discussing more number methods of preparations. So you can, if you have any something like, look here, the first method from alkyl halide. So here what I am taking Ri. Ri means alkyl iodide. Okay, alkyl iodide. So when it is treated with alkyl iodide, so when it is treated with mercury, Hg, Hg is a metal. So what will happen? There will be a formation of compound called RHG high. So what is the name of RHG high? Alkyl mercuric iodide. Alkyl mercuric iodide. Otherwise, iodo-alkyl mercury 2. Okay. Whichever way you want to say, iodo-alkyl mercury 2 is the IUPAC name. So alkyl mercuric iodide is the common name or trivial name. So same this alkyl mercuric iodide, when it is treated with uh, organolithium, so it is possible to form a dialkyl mercury. So R dash Hg is called the dialkyl mercury. So this one, of course, LiX is a byproduct. It can be removed. This is a liquid. This is a solid. Okay. So overall, maybe by by isolation process, this can be isolated. So one method of preparation of alkyl mercury is by the reaction of alkyl iodide with mercury. So the obtained alkyl mercuric iodide, when it is treated with organolithium, alkyl lithium, it leads to the formation of dialkyl mercury. This is the one method. So let's look into the another method also from organomagnesium and organolithium compounds. So here I am taking organolithium. Organolithium, when it is treated with mercuric halide, HgX2 means mercuric halide. So what is the product obtained? The product obtained is alkyl mercuric halide. alkyl mercuric halide. So when it is treated with organolithium, it gives dialkyl mercury. So what from these two, this is the product, this is the intermediate, this is the product. So that means a dialkyl mercury is also obtained by the reaction of uh, organolithium. Otherwise, what we can say that two molecule of organolithium on reaction with the mercuric halide gives dialkyl mercury. So that way also we can say. Then one more method, it is from the organometallic halides. This is an organometallic halide. When it is treated with mercuric halide, so there will be a replacement. Magnesium is replaced by mercury. So the obtained one is alkyl magnesium halide. The obtained alkyl magnesium halide uh, can react with one more molecule, one more alkyl mercuric halide, giving rise to dialkyl mercury. So overall, what you can remember in the second method of preparation, dialkyl mercury can be obtained by the reaction of organomagnesium compounds or organolithium compounds when it is treated with mercuric halide. So that you can take the message from this slide. Okay. So then let's look into the one more method of preparation. I will go to the next slide. So from trialkyl boranes, how do we get a trialkyl borane? Borane, when borane means BH3, diborane means B2H6. Borane or diborane, when it is treated with alkene, so it gives triborane. This triborane, when it is treated with mercuric acetate, HgOAc twice, mercuric acetate. What is the product obtained? The product obtained is alkyl mercuric acetate. This alkyl mercuric acetate, right. Okay, here I am taking an example. So this is a general reaction, and the byproduct is triacetoxyborane. It's a byproduct. It's the product. What is the name of this product? Alkyl magnesium acetate. So this is one example I am taking. Of course, this is also a general example, but here R may be a alkyl or aryl group. It's a borane. Tri means a trialkyl, trialkyl or alkynyl. Alkynyl, because double bond is there. Trialkynyl borane. Trialkyl borane, when it is treated with mercuric acetate, diacetate, it leads to the formation of what is called as alkyl, okay, mercuric acetate. Alkyl mercuric acetate. So is the organometallic compound. Now, I think you are aware about the electrophilic substitution reaction. Okay, similar to the electrophilic substitution reaction. So mercuration. Okay, if the mercury is added to the aromatic compound, it's called mercuration. If mercury is removed from the organic compound, it's called demercuration. Okay, so here in this reaction, so we are adding mercury to the organic compound. Okay, that is the reason it's called mercuration. So Hg plus is a electrophile. Hg plus is a electrophile in nature and gives electrophilic substitution reactions with aromatic compound. So most common mercuric reagent is the mercuric acetate in acetic acid. Acetic acid is a solvent. Okay, and this reaction means mercuration reaction is catalyzed by the perchloric acid. Okay, I think you are perchloric acid means it's a per acid. So this is an aromatic compound. So this aromatic compound, when it is treated with uh, uh, mercuric acetate, dimercuric acetate, diacetoxymercuric 2. So what is the form? So one acetoxy is going out, means acetic acid is going out. So then the bond pair means aromatic double bond means electrophilic substitution reaction. So form a bond with this mercury. So that is how a phenyl mercuric acetate is the product is obtained. Suppose if there is a substitution. So look here. Here there is a methoxy is a substitution. So you know that methoxy means it's a electron releasing group. So electron releasing group means what will happen? What is called as I think you are aware about the orientation. Okay, the incoming electrophile orients. Okay, because a substituent already present in the benzene, so that substituent orient the incoming electrophile. So methoxy is an electron donating group. It orients the incoming electrophile to the ortho position or para position because it's a electron releasing group. So methoxyhanisole orients the incoming Hg OAC to the para position. So that is how a methoxy. This is called methoxyphenyl. Methoxyphenyl. What is called as mercuric acetate. So with this, I will go to the next slide. So in the next slide, I am discussing about the what is called preparation or synthesis of mercuric halide organomercury compound, starting with the diazonium salt. So what is diazonium salt? N2X. Okay, N2X containing compounds are called diazonium salt. Here ArN2X. ArN2X means it's a diazonium compound. So this diazonium compound, when it is treated with the mercuric halide, so HgX2. So what will happen? There will be a reaction. So what is the reaction? N2 will be going out. N2 is going out means what is the product form? The product formed is ArHgX. What is ArHgX? Ar is a aromatic compound. So that means aryl mercuric halide. Aryl mercuric halide is the product. Okay, this is what is called nitrogen is releasing. It's a gas, it will go out. So overall, what we can say that diazonium salts, when it is treated with mercuric halide, it will give you aryl mercuric halide as the product. So then this aryl mercuric halide, when it is treated with copper, okay, in presence of ammonia, so it leads to a diaryl mercury. So that means this aryl mercuric halide, when it is treated with a catalyst called copper, so that leads to the formation of diaryl mercury. Diaryl mercury is a what is called as organomercury compound. So one more method of preparation of organomercury compound is starting with carboxylic acid. So more particularly aromatic carboxylic acid. So what will happen? Aromatic carboxylic acid, when it is treated with mercuric halide, it gives what is called as mercuric carboxylate. This mercuric carboxylate undergoes photo decarboxylation. That means mercuric carboxylate, when it is exposed to the light source, so it undergoes decarboxylation, giving rise to diaryl mercury. So this is another method of preparation of diaryl mercury. So diaryl mercury, it is possible to synthesize starting from a diazonium compound. Diaryl mercury, it is also possible to prepare starting from the carboxylic acids, aromatic carboxylic acids when it is treated with mercuric halide. Initially, it will form a mercuric salt. This mercuric salt, on exposure to light or photo decarboxylation, giving rise to diaryl mercury. And then now I am using one terminology called salvo-mercuration. So here salvo means is a solvent. Okay, salvo means solvent. Mercuration means Hg is added to substrate. So what it means salvo mercuration? Salvo mercuration means a mercury as well as the solvent is added to the substrate. So here Hy is a solvent, HgX is a mercuric compound. So that means Hg is also added to double bond, and what is called as solvent is also added to the double bond. It is nothing but a addition reaction. So salvo-mercuration means addition of solvent as well as mercury to the substrate is called salvo-mercuration. So here example is an alkene I have taken. So alkene, when it is treated with mercuric halide, so in presence of solvent, so Hy is a solvent. So what is happening? Hg will add to one carbon, and I think you know that what is called as the bond pair present in the alkene attacks Hg. So that means there will be a new bond formation like HgX. Once there is a bond pair as used in a bond formation, this carbon attains a positive charge. Suppose if we are taking methanol as a solvent, lone pair present on the oxygen attacks here and forms a bond. So that is what the obtained compound is called salvo-mercuriated product. So there are questions on this. What is salvo-merculation? Explain with an example. Okay. So instead of R, if we are taking any methyl or ethyl, so that will be one alkene. So this alkene, when it is treated with mercuric, instead of X, you can take any bromide or iodide or fluorine. So instead of Y, you can add methoxy, means methoxy group, acetoxy group, carboxylic group. Okay, maybe you can also take methanol, ethanol, propanol, butanol, pentanol, hexanol. Okay, so the product is this. So with this, I will go to the next slide. So here I am explaining about the mechanism. So initially HgX, it will be in equilibrium Hg plus X. Hg plus, here Hg is in the cationic, means electron deficient or electrophile here. X minus, it's a nucleophile. So what will happen? The bond pair present on the alkene, it will react with Hg plus X. So that is how a bond formed, a positive charge. This was attacked by Y minus. Y minus is a solvent part. So that is how a product is obtained. So look here, I am taking an alkyne, a triple bond one. So to this triple bond, if we are adding a mercuric acetate, what will happen? There will be a new bond formation between this carbon and of course this carbon and HgOAC. Since acetic acid is there, ACO means acetoxy group, so that will come over here and form a bond. So here two possibilities. So based on the R group, if the R groups are bulky, then Hg will add to less hindered position. Acetoxy will add more hindered position. And here there is a double bond that you need to write. Okay, this is about what is called salvo-mercuration. Salvo-mercuration means you need to remember that mercury as well as the solvent is added to the alkene or alkyne. So that's what you need to remember with respect to the solvomercuration. So here I am taking one more method of preparation. So starting with phenyl mercuric bromide. So what is the name of this compound? This is C6H5 means phenyl, Hg means mercury, Br means bromide, phenyl mercuric bromide. Phenyl mercuric bromide, when it is treated with the chloroform, CHCl3 is called chloroform. So what will happen? Tertiary butoxide. This is a tertiary butoxide. So a tertiary butoxide is a base. So what it will do? It will capture a proton. Where is the capture? Capturing proton. I think CH is there, no? That is only. This proton is captured by tertiary butoxide. What is the leaving group? The leaving group is tertiary butanol. Then there will be anion formation, C 2 electron and K plus. Okay, that will act as a anion and attack this mercury. Br is going out. So what is the leaving group now? So tertiary butanol is one leaving group, potassium bromide is another leaving group, and this C, it will form a bond with this Hg. This is one compound you need to remember because there is a application of this compound. So what is the name of this compound? Phenyl. Phenyl means pH. And what is this? Trichloro. Cl3 means trichloro. Methyl. Methyl means one carbon is there. And this is the mercury 2. This is the IUPAC name of IUPAC nomenclature of this compound. That means phenyl trichloro methyl mercury 2. Okay, this compound application is there. I will talk about later. This compound used as a reagent for the cyclopropanation. Okay, that I will discuss later. So with this, I will go to the next slide. Okay, next I am talking about the reactions. So up to this, we discussed about the preparations. So now let's look into the reactions of organomercuric compounds. This organomercuric compounds reactions depends on two factors. So one is organomercury compounds are very weak nucleophile. Organomercury compounds are very weak nucleophile and react only with very reactive strong electrophile such as X plus. X plus means Br plus or iodine plus. Okay. H plus means acidic source. H plus proton, maybe from the HCl or maybe from the sulfuric acid, maybe from the PTSA, and then acetyl group. Acetyl group means RCO plus, or maybe a alkyl group. Alkyl may be a methyl ethyl propyl. And one more parameter, the bond CHG bond means carbon mercury bond are more covalent character. If there is a more covalent character, that means it's a weak bond. So hence what will happen, there is a possibility of homolytic cleavage. So homolytic cleavage means this mercury takes its electron, methyl takes its electron. So that's called homolysis. Homolysis, it's a free radical formation. So weak covalent bonds undergo homolysis. Homolysis means breakage of bond. So if the homolysis means the shared electron taken by the participant elements. So what is the, suppose this bond breakage means Hg taking its electron, methyl taking its electron. So that is how here one electron is obtained. So what is the energy is required to break homolysis? Activation energy EA, that is 213. So what it means? It means that first ionization energy is more for homolytic cleavage. So whereas the second one means breakage here. So it is less only 32 kilojoules per mole. So that's what thing you need to remember. So what it means? It means that organomercury compounds can react with electrophile, okay, strong electrophile. It also undergoes cleavage, homolytic cleavage, and thereby gives products. Okay, that's what you need to remember. So now with this information, we'll go to the electrophilic substitution reaction. So what is electrophilic substitution? I think you are aware that aromatic compounds only exhibit the electrophilic substitution reactions. So here we are looking at the replacement of mercury by electrophiles. So what it means? It means that mercuration. So mercury is added to the aromatic compound, and then that mercury is replaced with electrophiles. Okay, for example, bromine, for example, iodine. Okay, more particularly Br plus, I plus, Cl plus, acetyl plus. Okay, it's a demercurated. In that, a electrophile is added. So that's what the reaction. So let's look into the example. So look here, I am taking, this is a anisole, ANISOLE. Anisole means methoxybenzene. So when methoxybenzene, when it is treated with mercuric acetate, so what is the product it's obtained? The obtained product is uh, methoxyphenyl mercuric acetate. So what it means? There will be a new bond formation between this carbon and this Hg, and there will be a removal of acetic acid. This acetic acid is a solvent. Okay, so the product is obtained. Now what you can observe, HgOAC, HgOAC. Here OAC, it is possible to replace with chlorine. So this moiety, when it is treated with sodium chloride, OAC is replaced with chlorine. That means mercuric chloride. Methoxyphenyl mercuric chloride is obtained. And what is the leaving group here? Sodium acetate is the leaving group. So so this moiety, okay, this is a mercuric compound. So here this mercury group is replaced with bromine in one reaction. This mercury group is replaced with iodine in another reaction. So in this the leaving group is HBr, in this the leaving group is HI. HBr is a gas, it will go out. HI is a gas, it will go out. Okay. So so what will happen actually here? This bond pair picks up this I, and I minus picks up this HgCl. So going out. Okay, HgICl is the byproduct. In this Hg BrCl is the byproduct that will go out. So this product is obtained. What is this? Methoxyphenyl bromide. Methoxyphenyl iodide is the product. So what is the, can you tell me the other method for the preparation of iodo or bromo compound? So what you need to do? You need to take a benzene and you have to do a nitration. So when you are subjecting to a nitration, it may be possible to get a orthonitro as well as a paranitro. So that you have to separate it. After the separation, you have to take para, and that was subjected to reduction. And that reduction you will get amino compound. That amino is subjected to diazotization, and then it was subjected to Sandmeyer reaction. So how many steps are involved to get phenyl iodo or phenyl halide? So many steps are involved. So this may be the better method. Okay, here just treating with mercuric acetate. This mercuric acetate is replaced with chlorine. Means acetoxy is replaced with chlorine. So this and just treatment with iodine in acetic acid, or otherwise add iodine and heat. You will end up with methoxyphenyl iodide.
So if we are going for another way, nitration is one step, separation is another step, reduction is another step, okay, and then diazotization is another step, and Sand-Meyer's reaction is another step to get this type of compounds. And we know that diazotization giving only the less yield, 40% yield, 30% yield, and right. So I will go to the one more, that is called acetylation. So for this acetylation, I am taking this group is called vinyl group, vinyl mercury chloride. So this vinyl mercury chloride, when it is treated with acetyl chloride, so what will happen? There will be a new bond formation. How the new bond formation? This bond pair can attack this carbon and Cl is going out. So that is how an intermediate formed is obtained. So at this stage, this bond pair is coming over here and the Cl minus attack this Hg. So that is how HgCl2 is going out and forming a alpha beta unsaturated carbonyl compound. Of course, we can say that this is an acetylation. More particularly, acetylation of olefins. Olefins means double bond containing ones. So this is about another electrophilic electrophilic. Here the electrophile is CH3CO. CH3CO is added to the what is called mercuric compounds. With this, I will go to the next slide. So here I am talking about the solvomercuration and demercuration. Solvomercuration means you should remember that addition of solvent as well as mercury compound. So here the reactant or the substrate is double bond. Double bond means alkene. So to this alkene, mercury Hg as well as OAC is added. Okay. So OAC will add to this carbon. Okay. And what I think you are aware about the what is called as one acetoxy group is going out and this bond pair is attacking this Hg. So that is how Hg acetoxy is obtained. This is not Cl, this is acetoxy. So once there is a bond pair is involved in a bond formation, this carbon attains a positive charge. The solvent present in the reaction mass attacks here. So here water is present in the solvent, it will attack this carbon. So the product is obtained this. So what is the name of this product? So you know that hydroxy. But we can also say that oxy. And this is mercury. And the conversion of alkene to oxymercury, we can say that it will be a oxymercuration. So in the first step, mercuration, and in the second step, oxy is added. So the obtained one is oxymercuration. And here, what is the reagent used? A sodium borohydride. Of course, it's a reducing agent. It will act as a source of hydrate. So what it will do? It will add hydrate to this carbon. This Hg takes up this bonded pair. So that means it's called demercuration. So in the first step, mercuration. In the second step, oxymercury. Oxygen is added to substrate. In the third step, demercuration. Removal of mercury group. How it is removed? By with the reducing agent. So now I think here I have written a 2 intermediate. Sometimes they will ask you, they will give you alkene. And in the first step, it was treated with HgOAC twice. In the second step, it was treated with sodium borohydride. So here there will be a question mark. So you have to write the product. This will be the right product. These two are not the right product. So similarly, here I am taking one more alkene. Its a substituent is different. This is a general or maybe alkyl or aryl group, but this is a specific reaction, a specific substrate. So what will happen? This bond pair form a bond with this Hg, removal of acetic acid. That is how intermediate is obtained. A positive charge is there. So the solvent present in here is an alcohol. So alcohol, where the alcohol may be methanol, ethanol, propanol, because it is mentioned as a HAR. The bond pair, this is the bond pair or the lone pair, will attack this carbocation. So forming a compound like this. This you can say that oxymercuration. Okay, this product is oxymercurated product. So here, from here to here, a demercuration. So what is the source used for the demercuration? Sodium borodeuterenium, tetra deuterenium sodium borate. So here D minus will act as a source. That D minus attack this carbon and this Hg going along with this bonded pair. It's a living group and this is the product. Okay. So similarly, this is one more. But what is the changes? So here an alcohol, but here an water. That is how OH is there. That's all. So the difference between here and here solvent used as alcohol, here water. Okay. So with this, I will go to the next slide. So this is one example I am taking. So here I have written a long chain. Okay, suppose if I am writing, instead of going like this, if I am writing down, so it will come like this. And one more thing, so this moiety is added to mercuric acetate. So what it means, there will be a new bond formation between this carbon and this Hg. How it will form? This bond pair are used in a bond formation. If this bond pair are used in a bond formation, this particular carbon attains a positive charge. That's what I have written here. This carbon attains a positive charge. Since there is a positive charge, the lone pair present on this oxygen are the bond pair. What is bond pair? OH bond pair. Can attack this carbon, form a bond. What is called now tetrahydrofuran is a product. And at this stage, sodium borohydride used. So when there is a use of sodium, here itself, sodium borohydride, so HgOAc is replaced with H. So that is how the product is obtained. So similarly, this is the compound. So first there will be a new bond formation between this carbon and this Hg. There is a formation of positive charge. That's what I have written here. There will be a new bond formation between this oxygen and this carbon, a bicyclic compound. And when it is treated with the sodium borohydride, HgOAc, demercuration, okay, is replaced with H. That is how product is obtained. Okay, and then what will happen? So this is one more compound. What is the name of this compound? Cyclohexyl ethylamine. More particular double bond is there, cyclohexenyl ethylamine. So when it is treated with what is called as mercuric acetate, so this is the double bond. This there will be a new bond formation between this bonded pair and this Hg. So this Hg, it won't add to this carbon. It will add to this carbon because if it is adding here, it will be hindered. So that is the reason it will add here. A positive charge is formed here. That's what I have written. And the lone pair or the bond pair will form a bond over here. So that is how a heterocyclic compound is obtained. So this is about the mercuration and demercuration. Mercuration means HgOAc twice. Demercuration means using sodium borohydride. So with this, I will go to the next slide. So next slide, I am talking about the cyclopropanation. So what is cyclopropanation? A cyclopropane ring is formed. How it is formed? By using a phenyl mercuric, phenyl trichloromethyl mercury 2. So this is the reagent. This reagent we prepared. How we prepared? So this was prepared by treating with the phenyl bromide and what is called as chloroform. Okay. Phenyl magnesium bromide when it is treated with chloroform in presence of base. So this is the product is obtained. This product is used finds application in the cyclopropanation. Cyclopropanation means a cyclopropane ring is formed. With how it will form? It will form by reacting with an alkene. Okay. So what is the this is an alkene when it is treated with phenyl trichloromethyl mercury 2. So here I am written a mechanism. This reaction is catalyzed by iodine. Iodine, sodium iodide, I minus. I minus can form a bond with this mercury. CCl3 anion is going out. This is the CCl3 anion, means two bonded pair electron here. So this one Cl is going out. Then it's called carbene. This is the carbene, dichlorocarbene. This dichlorocarbene with one electron, it will form a bond here. With another electron, it will form a bond here. So that is how cyclopropane is obtained. This process is called cyclopropanation, and the reagent is called phenyl trichloromethyl mercury 2. This is about cyclopropanation. So I will so in this organomercury compound we discussed about salvomercuration as well as cyclopropanation. So there are questions on salvomercuration, there are questions on cyclopropanation. Okay. So with this, I will go to the next slide. Next, I am taking the examples. So this is one alkene. This alkene, when it is treated with phenyl trichloromethyl mercury, so C, this group, Cl2 group will add to this double bond and a cyclopropane is obtained. Similarly, this double bond is there now. To this double bond, CCl2 is added, cyclopropanated. And here I am taking one more compound, a 4-membered ring. So here this is a oxygen, a carbonyl compound. This is an alkene. To this alkene, when it is added phenyl trichloromethyl mercury, cyclopropanation happens like this. Suppose this moiety is treated with ethanol in presence of HCl. So ethanol means the lone pair or the bond pair attack this carbonyl carbon, and this bond pair picks up a proton. So that means ester here, alcohol here. So this is a further reaction. This is about what is called as organomercury compound. So today we discussed about organomercury compounds, more particularly its preparations and reactions. Under the reactions, electrophilic substitution reaction, replacement of mercuric compounds with electrophile, and also under the reactions we discussed about salvomercuration, addition of solvent as well as mercury, and also we discussed about mercuration and demercuration. So mercuration means mercury compound is added to the double bond. Demercuration means demercurated by treating with sodium borohydride. So this is about today's class. If you have any doubt up to this, you can ask question. If there is no doubt, means